Hey everyone, welcome back. Been a while, or maybe not. Today we're talking about beacons. Now, obviously, from the title of the video, and also the fact that it's the really only useful part about beacons, nobody cares about any of this garbage anyways, we're going to be talking about the colors, and basically how stained glass influences the color of any given beacon beam. So to start off, I want to start with this very simple setup here. We've got red glass, blue glass, and lime glass, and I want to see if you can predict what kind of color will come out of the top here. And if you guessed this color, which you probably definitely didn't, then you might be a little bit confused, and that's because beacon color mixing is really complicated. Well, actually not that complicated, because you're certainly going to know exactly how it works by the end of this video, but it's complicated to the point where it's really unintuitive to learn yourself. So let's get right into it. So let's start off with these two beacons. Here it might be really easy for me to communicate to you that order does not matter, because here we've got blue and red, and now we've got red and blue, and obviously these two beacon beams are the exact same color. But if we look at these two sequences, they're obviously not the same color, even though they contain the same amount of each color. So obviously there's some fishy nonsense going here where order seems to only matter some of the time, whereas other times it seems to have a major impact on the actual outputted color. And the reason why is because beacons don't use a very standard additive or subtractive color mechanism that a lot of real-life stuff uses, but rather employs its own entirely different percentage-based system that does actually place value on height of the glass, but only in certain situations. Okay, so let's talk about exactly how it works. If we look at the original setup before, RBG, which I just realized is out of order, is 50% red, 25% blue, 25% lime. And the reason why this organization happens is because each and every piece of glass, looking at the blue glass for example, takes the input color and swaps exactly half of all of its percentages with the new color. So if we actually look at a clean green plate, the blue glass takes half of it, converts it all to blue, and that new color enters the red glass, which takes half of that, and converts it all to red, leading us to have 50% red, 25% blue, 25% lime. Now, one more important thing to note, the reason why I didn't start out with the lime glass turning the white beacon beam into lime, as a white slate being half converted to green, is because this isn't actually a white beacon beam. See, the thing is the very first beacon beam actually ejected out of the beacon is not really white, it's actually just a blank slate that takes on the fully saturated color of the first glass it enters. If you actually want to see what the influence of a white beam entering the system actually looks like, we can convert this white beacon beam into an actually white beacon beam and see the effects of what we'd be expecting. Also, one more dumb fact, for some reason other beacons act as white, even though they very obviously have clear glass, which doesn't actually change anything. I don't know. Okay, so I've taught you basically everything you need to know about the theory behind it, so how do we actually apply this and make stuff like this? Well, to start off, let's break it down to a single beacon beam first. When broken down like this, you can essentially expect to see that the bottom two glass will have the exact same percentage of influence on the beacon beam, and each rising one above that has exactly 2 times the level of influence. Now, since we're using exactly 2 colors, and each piece of glass one after another has exactly 2 times as much power, this is beginning to seem like it's developing into a pattern of binary counting. And if you don't know exactly how binary counting works, I'll give you the quick 20-second explanation that's necessary for the video. Essentially, it's a number system in which you count with ons or offs, or ones or zeros, where basically you assign a different value to each place where the 1 or 0 could lie, and it's set up in such a way that allows you to access any number within a given range. And the reason why this is so useful is because if we fly back over here and analyze the influence each beacon glass has on the beacon beam, we can see that apart from the bottom 2, it does actually count up by factors of 2. And if we want to access every single color value between one solid color and another, we just simply count by binary, accessing every single value with no overlap. If you actually want to learn about binary in general, make sure to look up a video on that. There's a bunch of better explanations. I just wanted to mention the details of why it's important to this. Now, let's talk about beacon binary, or whatever you want to call it. In order to simplify things, I've gone ahead and labeled things in units instead of percentages, and there are 16 units that constitute a full color. Obviously, these bottom two have the same influence, and for the rest of the way, it scales by multiplying by 2. This first one, we have 16 units of purple because it's all purple, and here we implement a single unit of red. Next, we swap it out for a double unit, one on the 2 layer, so it adds 2, so we have 14 purple, 2 red. Then we have both of them, 1 plus 2 equals 3, 3 red. Then we swap those both for 4. And then we get 5, which is 1 plus 4 equals 5 red. We keep scaling things up until we eventually get to the end here, where we have 15 red and 1 purple, and we can swap that last purple for a red to get us that final 16. In terms of total number of beacons, this equates to 16 beacons per color, and that just means that since I have a purple, red, orange, yellow, lime, cyan, blue gradient here, that's 7 times 16, so 7 times 16 beacons. There is one more little thing I'll mention too, and that's going to be about making a really weird decision. See that important bottom layer that I just spent a while talking about? What if I just homogenized it into a single chunk of white stained glass? You're going to see that our beacon gradient actually stays mostly intact. There's a couple things to say about this. Number one, why the hell would I even do this, which is very reasonable. And number two, why does it still work? I'll answer the second one first. The reason is because by wiping out the bottom layer, we've essentially just knocked out this original 1 unit thing, which kind of removes a bit of complexity, and now we're just working with normal binary again. This does come at the added consequence of having an extra solid color beam at the end of every single cycle, but we can just knock that out, and that reduces our total to 15 beacons per color, or 15 times 7 for this beacon gradient. There's also the thing of it undoubtedly getting a little bit lighter, although negligibly so. If we look, here's me switching between the two. It's mostly noticeable in the darker section of the blue, but still basically non-existent. So now onto the why. Why would I do this, and why would I show you that it's possible this way? Well, the reality is that we know there's basically no change, and if we know that there's a bunch of slop at the bottom here that we can just cut out to have a negligible loss, why don't we just cut out the extra complexity and roll with having a solid white base layer? This becomes especially handy if you're designing a gazillion automatic rainbow beacon machines, and you want to cut out that extra layer of complexity on the bottom by just knocking it out and swapping it with white stained glass. If we actually go to an operating version of this machine, we can see that we only need modules for the glass that we're switching, and if we don't have to switch the bottom one and we can just swap it with a base layer, that saves us a lot of effort. And if you were to make this hypothetical beacon machine run on binary systems, you definitely not want to have to deal with an entirely separate module that doesn't run on binary. But it doesn't really matter, because that's all hypothetical. That video hasn't been made yet. But that doesn't mean that this video right here wasn't just an incredibly elaborate setup to both prepare you and to convince you to watch the next video on automated rainbow beacon displays. So, if you want to see me take all of that theory nonsense you just learned for no reason and turn it into something that's actual practice, make sure to subscribe and I'll hopefully see you there. One more detail before I head out. I've already actually made a video on beacon color theory, but that previous one was a total heap of garbage and completely wrong. If you want to see the details on that, make sure to check the description. Also, make sure to join the Discord, like and subscribe, and I'll see you next time.